The next largest subnet is New York sales, which requires 14 hosts. So I want you to pause the video again here, calculate the optimal subnet mask for New York sales, and again determine the network and broadcast addresses and the range of available host addresses. Okay, so stop the video now. I'll see you in a second once you've worked that out. Okay, so let's look at the answer. We need to support 14 hosts. The smallest possible subnet we can use is a /28. /28 means we've got 4 bits available for host addresses. So that's 2, 4, 8, 16 minus 2. That gives us the 14 hosts. 200.15.10.0 to 200.15.10.63 were already being used by the engineering departments. So the network address that we'll start with here is 200.15.10.64. If we look at the line, we can see it's after the 16. So 64 plus 16 is .AA. Take one away, our broadcast address is going to be 200.15.10.79, and the available host addresses 200.15.10.65 to 200.15.10.78, the addresses that are between the network address and the broadcast address. Okay, that's our first 3 departments done. The last department was Boston sales, which requires 7 hosts. So let's do the same thing again, calculate the optimal subnet mask, and then the network address, broadcast address, and the host addresses that we're going to use. So stop the video now, and I'll see you back with the answer. Okay, so we need to support 14 hosts. We're going to use a /28 again here, the same as what we did for the last department. You can use a /29, which is a possible mistake that some people would make, because we need to support 7 hosts, so they go 2, 4, 8, okay, that's 3 bits, and they'll make it a /29. They forgot to take away the 2 for the network address and the broadcast address. Okay, a /29 supports 8 minus 2, 6 hosts. We require 7 here, so that's enough. So we're going to use a /28 again, which supports 14 hosts. The last broadcast address was 200.15.10.79, so our network address will be 200.15.10.80. Again, the line is after the 16, so the next network address would be .96, which means our broadcast address is going to be 200.15.10.95. The valid host addresses are .81 to .94. Okay, so that's it. That was our 4 departments, so we're done, right? No, remember we have to allocate addresses for the point-to-point link between the routers in Boston and New York. Another thing you would do in the real world is you would also allocate address space for your loopback addresses. Loopback addresses are used for management. They're a logical address, so there's not anything physical on the other end, so we'll usually allocate a /32 to our loopback addresses. Again, we'll talk about loopback addresses more in later lectures. Don't worry about them for now, I just mentioned it here for completeness. Okay, so that last subnet, the link between the New York and Boston routers. So let's do the same thing again. Pause the video, determine the optimal subnet mask and the network, broadcast addresses, and the host addresses that we're going to use. So pause the video and I'll see you back with the answer. Okay, so we want to support 2 hosts. Remember, a /31 or a /30 supports 2 hosts. And hopefully you remember I told you before, unless the exam explicitly tells you if you need to support 2 hosts, go with a /30 because that's a standard that we use. It complies with all of the internet standards. So we're going to use a /30 here for our 2 hosts. We're already using up to 200.15.10.95 for our departments. So our network address will be 1 up from there. We're going to use 200.15.10.96. If you look at the line, it's after the 4. So the network address is going to go up in increments of 4. So the next network address would be 200.15.10.100. 1 less than that gives us our broadcast of 200.15.10.99, which leaves the host addresses to be .97 and .98. Okay, one more thing that I want you to do. I want you to have a look again at the network topology diagram that you saw at the start of this lecture. You don't need to scroll back. I'm going to put it up on the next slide. Then what I want you to do is get a piece of paper and a pencil, and I want you to draw the network diagram. But this time I want you to include the networking information, the different subnets that we just figured out. So make it look, here, let me go on to the next slide. So make it look exactly like this with the routers and the switches, but rather than saying sales 14 hosts, I want you to say sales, and then I want you to tell me the subnet that is going to be in use here. So the subnet and the subnet mask in slash notation. Do that for the 4 departments. Also do it for the point-to-point link. And another thing I want you to do is also put on the IP addresses that will be used on our router interfaces. For the router interfaces, use the first available host address in that particular subnet. Okay, so get your paper and pencil out. Go ahead and do that now. On the next slide, I'll show you the answer. Okay, so here we are with the answer. Remember when we did our design, we started off with the largest subnets, which was the engineering departments. So the way I would do my network diagram is I would show engineering in New York. That was 200.15.10.0/27. In Boston, 200.15.10.32/27. I've then got my sales department in New York, 200.15.10.64/28, and sales in Boston was 200.15.10.80/28. And the subnet I used for my point-to-point link, 200.15.10.96/30. Then we're going to use the first available address as the IP address on our router interfaces. So that was .1 on the interface on the New York engineering department, .33 for engineering, .65 for New York sales, .81 for Boston sales, and then the point-to-point link, I'm using .97 on the left and .98 on the right. Okay, and this would be an acceptable network diagram in a real world environment. This is typical for how we would draft that up. Okay, that's it. So you now know how to do a variable length subnet mask design for a network. See you in the next lecture.